Now, energy is the ability to do work or move things around or heat. And so we need to define units for energy. And what we're going to use is a relatively old unit that's been around for a while. It's not SI, but it's used a lot. And that's something called a calorie. And a calorie is defined as the amount of heat or energy to raise 1 gram of water, H2O, by 1 degree Celsius. And the way that works is like this. If you have a test tube and you were to have 1 milliliter, which is 1 gram of water, and you put a thermometer in there, and you pass a flame from the Bunsen burner, and when that temperature goes up 1 degree from here to there, 1 degree Celsius, you just added 1 calorie. And so if you go up 10 degrees with that 1 gram of water, then you added 10 calories. And if you have more water, it takes more calories to heat it up by however much you want to heat it up by. Okay, so that's a calorie. So that's the amount of heat energy to raise 1 gram of water by 1 degree Celsius. Now, the SI unit is something called a joule. And a joule is 4.184 joules equals 1 calorie. Exactly. Now, we're not going to use joules in our calculations, even though the textbook does use joules in some of the calculations, but generally we're going to just stick with calories. But if you do have to convert back and forth between joules and calories, you can use the conversion per calorie, 4.184 joules per calorie. And of course, you set it up as a conversion, and you can go back and forth in between joules and calories, making sure that our units cancel. Okay, and so that's the calorie. Now, a food calorie, on the other hand, is what's called a big C calorie, as opposed to a little c calorie, which was the calorie definition, and that is a kcal, which is a kilocalorie, which means you have 1,000 calories, little c calories. Now, I don't like to use big C for calories, but it's used in nutrition on labels for food. If you look on the back of, say, a bag of Doritos or whatever, it will say so many calories per serving. Well, those are big C calories. Those are actually kilocalories. So if something has 150 big C calories or kcals, well, that's the same as 150,000 calories, because there's 1,000 kilocalories, that 1,000 calories for every kilocalorie. And so those are big C calories, and that's what you find on the back of food products, is big C calories. Now, it turns out that if you know the grams of fat, and if you know the grams of protein, and if you know the grams of carbohydrates, you can actually calculate the food value or the kilocalories in that item. And so the values that we have is that fat is 9 kilocalories per gram, and that carbs are 4 kilocalories per gram, and protein is also 4 kcals per gram. And so if you know how many grams you have, well, you just multiply it times the kcals, and then you add them up. So let's say we have a cheeseburger, and we're told that it has, let's say, 151 grams of protein, and it also has, let's say, 20 grams of fat, and let's say 15 grams of carbs. We can figure out how many kcals are in that cheeseburger. And it's real easy. You just multiply times the food value for each one. So protein is 4 kcals per gram. Fat's 20 kcals per is fat. 20 grams of fat is 9 kcals per gram. And then carbs is 4 kcals per gram. And all we have to do is put this in our calculator and add them up. And we have the total kcals for that cheeseburger. And so I'm going to go ahead and put this in my calculator. So say 451 times 4, and that gives me 1804 kcals for the protein. And now we have 20 times 9 for the fat, and that's 180 kcals. And we have 15 times 4 for the carbs, and that's 60 kcals. And all we have to do at this point is just add them all up. So we go 1804 plus 180 plus 4 equals 1,988 calories. Those are big C calories, but I prefer to use kcals when I do these. Now, easy peasy, just add them up. All right. So let's change it just a little bit here, and we have something called specific heat. And the calculations start to get a little bit harder, but not much harder. Specific heat. And that is the amount of heat or energy to raise 1 gram of anything by 1 degree Celsius. Now, if you remember, the definition of a calorie looks very similar. And that was the amount of heat to raise 1 gram of water. By 1 degree Celsius. And if you look, they're very similar. And that's because the specific heat of water is 1.00 calories. Okay? And so it's essentially what you're saying, a calorie is the specific heat of water is the calorie. And so we say the specific heat, and I'm going to abbreviate it SH, for water is 1.00 calories per gram degrees Celsius. And we write it that way because it's 1 calorie for every gram for every degree Celsius. That's how we would say that specific heat, the way it's written out. And different things have different specific heats. And let me find a table here. And so something like aluminum would be 0.214 calories per gram degrees Celsius. And this is the specific heat of aluminum. And you can have something like silver is 0.0562 calories per gram degrees Celsius, and that's for silver. Okay, so everything has a different specific heat. Now, this is not something you have to memorize. You go look up your specific heats on tables, but it is useful because we're going to do a lot of calculations to remember that the specific heat of water is 1.00 calories per gram per degree Celsius. All right, so what are we going to do with specific heat? Well, we're going to have something first off, and here's our first equation that we need to work with. And that's something called the heat equation. And it looks like this. It is Q equals the mass times the change in temperature, that's what that triangle with the T, that's a delta T, times the specific heat. All right, now Q is the heat, and that's going to be in calories or joules. But mostly we'll do our calculations in calories. And the mass is grams. And the change in temperature is your end temperature minus your start temperature. Now, for our purposes, we'll generally try to keep it positive. So if you get a negative temperature change, which means the temperature was dropped, just go ahead and change it to a positive number. Technically speaking, if you have a negative number, that means you have released heat. And if you have a positive number, that means you've absorbed heat. And the specific heat you look up, and it's in degrees Celsius. Hold on. It is in calories per gram degrees Celsius. And you look it up. And for water, it's 1.00 calories per gram degrees Celsius. Now, if you set this up right, all the units are going to cancel except for the calories that you're looking for. And so if we were to put in just the units, you would see grams times degrees Celsius, that's the change in temperature, times calories for every gram degrees Celsius. And then you see that grams cancel, degrees Celsius cancel, and you're left with calories, which is what you're after in the first place. So that's a heat equation. And so you can calculate how much energy it takes to heat up something or how much energy it takes to cool something in calories. So let's do an example of using the heat equation. Let's say that we have a sample of, say, iron. So we take 15.9 grams of iron, and we're going to say the specific heat, and I'm going to look this up, and it is 0.108 calories per gram degrees Celsius, and it is heated, we're going to say is heated from 25.0 degrees Celsius to 33.0 degrees Celsius. And I want to know, how many calories was that? What was the calories? And so I see that there's a temperature change, so I know that when I have a temperature change for the calculations that we're doing, we're going to use the heat equation. Okay? And what we're going to do is we're going to look and see, what do we have? Do we have the mass? And we do. It's 15.9 grams. Do we have the change in temperature? Not yet, but we can calculate that, and that's 33.0 degrees Celsius minus 25.0 degrees Celsius, and that is 8.0 degrees Celsius. So that's the change in temperature. And the specific heat's 0.108 calories per gram degrees Celsius. So all we really have to do is just plug in our numbers. So we go 15.9 grams of iron times the change in temperature. Well, that was 8.0 degrees Celsius. And then times the specific heat, which was 0.108 calories per gram degrees Celsius. And I know I have this set up right because all the units cancel. And all we have to do now is just put it in our calculator. So we do that. We say 15.9 times 8 times 0.108. And that gets me 13.7 calories. And that's how much energy it would take to heat up that quantity of iron from 33 degrees Celsius, from 25 degrees Celsius to 33 degrees Celsius. And if you were to cool it from 33 to 25, it would be the same amount of energy, except you'd have a minus sign. Minus sign meaning that you were removing heat. Okay, well, let's do another one. Let's use water. So, how much heat calories to heat 127.2 grams of water? Let's say you're heating up some water in a beaker from room temperature, which is generally 25.0 degrees Celsius, to 100.1 degrees Celsius. That would be boiling point of water if the atmospheric pressure was a little bit higher than normal. And so, how many calories to heat this many? Now, notice in the problem, it doesn't give you the specific heat for the water, but it is something that you should know. So we know the specific heat of water is 1.00 calories per gram degrees Celsius. And if you can't remember that, you can at least look it up in a table. And so now we need the grams, the change in temperature, specific heat. We don't have the change in temperature yet, but that's 75.1 degrees Celsius. It's 100.1 minus 25, so that's 75.1 degrees Celsius. So now we go ahead and plug in our numbers. And so we say 127.2 grams times our change in temperature times the specific heat of water. And I know we're multiplying times 1, but don't leave off the specific heat just because you're using water, because at the end of the day, we still have to make sure always that units cancel, and they do, and we're left with calories. And so we say 127.2 times 75.1, and that gives me a pretty large number, but it's a lot of water, and that is 9,552 calories. And of course we need to do sig figs, and so this is 4, whoops, can't count today, 4, 3, and 3, and so we should have 3. And so remember how we do sig figs, we go 1, 2, 3, we have to keep the same size, so that's 9,550 calories. And if we wanted to, we could put this in kcals, and we could say 9.55 kcals, and that's also 3 sig figs. Okay, so that's using the heat equation. All right, so now that's when we have a temperature change. So when are we going to use the heat equation? So Q equals mass times delta T times the specific heat, and that we're going to use when we have a temperature change. Now, another equation is called the phase change equation. And it looks like this. It is Q, which is the heat in calories, times the mass, which is in grams, times something called delta H, which is the enthalpy. Okay, so Q is still calories, and M is still grams, but delta H is a number that you look up, and it depends on what's going on. Now, a phase change is when you go from like solid to liquid, or liquid to solid, or when we go from liquid to gas, or gas to liquid, or solid directly to gas, or gas to solid. Okay? And those are phase changes. And it takes a certain amount of energy to do each one of those phase changes. And for water, which is what we're going to use for all our calculations, but although every substance has different delta H's, from solid to liquid, which is melting, delta H is called delta H of fusion, and it is 80.0 calories per gram. Now, going back in the other direction, it's the same number, but we call that freezing. So if you're freezing or melting, you have something called delta H fusion, and it's 80.0 calories per gram. Now, if you're going from liquid to gas, we call that vaporization. And if you're going from gas to liquid, we call that condensing. Now, the number for that is going to be delta H is 540 dot calories per gram. I put the dot on there to make it 3 sig figs. And going directly from solid to gas, we call that sublimation. And going directly from gas to solid, we call that deposition. And its value is addition between the two of these, vaporization and delta H vaporization and fusion, and that would be 620 calories per gram, and that's delta H sublimation. Okay, and we're not going to do any calculations with sublimation or deposition, but it is a number that exists. And so which delta H you use depends on what it is that you're doing. Are you melting it? Are you freezing it? That's 80 calories per gram. Are you vaporizing or condensing? That's 540 calories per gram. Also, you can use the words boiling for vaporization as well. If you're boiling, you are vaporizing the water. Okay, so let's do some calculations with that. Okay, so how much energy to melt 18.0 grams of ice at 0 degrees Celsius? Of course, 0 degrees Celsius being the freezing point or melting point of water. Now notice there's no temperature change. Notice there's no temperature change. And that's to tell you that you do not use the heat equation to solve this problem. Use the heat equation if you have a temperature change. Now, when we have a phase change, such as melting or freezing, there is no temperature change. And so we need delta, since it's melting, we need delta H of fusion, which is 80.0 calories per gram. And so we're going to plug it into our phase change equation, and we're going to say that it's 18.0 grams times delta H of fusion, which is 80.0 calories per gram, and we're done. Keep in mind, when we said 80.0 calories per gram, that gram is there for canceling units purposes. So you cancel the grams, you're left with calories. And now we have a number that we can put in our calculator. So 18 times 80, and we have 1440 calories. And that's how much energy it would take to melt that amount of ice. How about let's try boiling some water? So let's say it's boiling and we want to vaporize every single bit of the water. So let's say we had 21.6 grams of water at 100 degrees Celsius, and we vaporized completely to steam. Well, there's no temperature change up here. And so if we're vaporizing, that means we need delta H equals 540 calories per gram. And so once again, we're going to use our phase change equation, which is the mass times delta H, except this time it's going to be delta H of vaporization. And we just plug in our numbers, and we say 21.6 grams times 540 dot calories per gram. And it's going to be a lot more energy. That's why steam burns are so much more dangerous than hot water burns, because you got 540 versus 1 calorie for every gram. And so it's 21.6 times 540. And we get 11,664 calories. And since we have 3 sig figs all the way across, that would be 117,000. So that would be 11,700 calories, or 11.7 kilocalories. And so we can do this also. Finally, we can actually do more than one thing at a time. How about if we melt some ice and then heat it up? So how about we melt 10.6 grams of ice at 0 degrees Celsius and heat to room temperature, which is 25.0 degrees Celsius. What do we do then? Well, now we have two things going on. We have melting, we have to melt the ice, and then we heat the ice. And the way you take care of these processes where you're doing more than one thing is you just do each calculation separately and just add it up. That's what you do. And so to melt the ice, well, that involves a phase change. And so melting is 80.0 calories per gram. So we say 10.6 grams times our 80.0 grams, or 80.0 calories per gram. And we put that in our calculator, and we go 10.6 times 80, and I got 848 calories. And now we have to heat the ice. Well, we're going from 0 to 25, so that is a 25-degree change in temperature. And so it's still 10.6 grams, except now we multiply times the change in temperature, which was 25.0 degrees Celsius, because we went from 0 to 25 degrees Celsius. And then we have to multiply times the specific heat of water, which is 1.00 calories per gram per degree Celsius. And then we put that in our calculator, 10.6 times 1.00 times 25, and I get 265 calories. And now all we do is we add up the two numbers. We add up the 840 calories to melt the ice, and then we add in the 265 calories to warm up the water, and we got 13 calories. And that's for both of these things added up together. So if you have more than one thing that's happening, you have to look at it and ask yourself what's going on. So I have to melt it and warm it. And we could even, melt ice, warm the water, and then vaporize it completely. And that would be three things that we have to calculate. And then we would just add it up at the end.